Aloha, I'd like to welcome you to the screencast for the Business 621 overview of data types and variables. This is pretty basic stuff, so you might want to just flip through the slides rather than watch this screencast, but you might enjoy watching the screencast too. I'll try to provide some additional information that might not be obvious from the slides. The first thing we want to talk about is what is statistics, and to know about what statistics is we have to start by understanding what the objective of statistics is. And the objective of statistics is to give reliable and unbiased or objective views of data that provide information in a structured way to help us make decisions. So statistics are things that take data, raw data and hard facts and things like that, and provide structured information that we use for making our decisions. The key thing here is that it provides objective and reliable. In other words, reliable means that we get the same, based on the same structured information the data would provide. If we use the same data, it ends up providing the same kind of structured information, which then leads us to the same kind of conclusions in an objective way. Now that differs from other ways that we can make our decisions. We can base our decisions on objective, structured, reliable information, but we can certainly make our decisions based on things like gut instincts and experiences and other kinds of things that take that hard data and facts. Like we might just say, well, it sort of feels like this is going to be a good thing to invest in, or my experience has shown that investing in tech companies has been a profitable endeavor. Now, those are perfectly fine ways to make your decisions if you are looking for just a way to make a decision based on information. But that's not necessarily going to be objective and reliable. In other words, our experiences vary from one person to another, and our gut instincts may change based on how we feel, for example. Or even perhaps our experiences. So while these are very valuable perhaps ways to use information for making our decisions, there are times for which we would want to be more objective and reliable about this, meaning that no matter who is asked, the statistics are going to be the same. And then the structured information that's presented for the decision making again will be based on some sort of objective characteristics rather than colored by how we feel or what experiences we've had. And so it should be the same every time. And then the thing about statistics is that it provides information, but it does not make decisions for you. You still get to make all the decisions. You have to make judgments and assessments of what that information means and how it's useful for making your decisions. All it does is help you provide information that is both objective and reliable, since you can add that to your other sources for decision making. Okay. Now, in statistics, the basic unit that we deal with in data is that we look at variables. And a variable is any sort of characteristic of an event or an object that we're interested in. So, for example, we might be looking at a spreadsheet here of homes, 1, 2, 3, 4, 5, 6, 7, 8 here, and say each home will have maybe a price, a square footage, its age, its bath, whether it has an air conditioner, what style is, garage, pool view, no pool, etc. So this information or this data about each of these houses is going to be organized as columns labeled by at the top with these variable labels. And so the variable here, say price, it represents all the different prices that could occur for various homes. In this case, we see we have a sample of these different prices, but the price label here represents all the different values that could be occurring for price. So it says we're interested in the price, and it's called a variable because the values here will vary or change according to the home. Now, another thing we want to look at is that by convention, we tend to organize data in a spreadsheet that we're going to use for statistics in this manner, where it's sort of columns represent the variables and the rows represent groups of related data. What do I mean by groups of related data? Well, here is home 1, which has this price, that square foot, that age, and that number of baths, etc., etc. So in other words, all the things in this row represent characteristics, particular characteristics for this home number 1. Similarly, for home number 2 has those values, number 3 those values. And the variables are organized as columns here. This is the price, that's the square footages, that's the ages. You could organize it differently, but if you do, you might confuse people. This is generally the way that people tend to look at statistical data in this sort of column variable format. So notice that column A is something special. So while these are all variables, column A is simply a label. It just says this is home 1, home 2, home 3. It's not actually data. It's just labeling what this, or some sort of identifier for this group of characteristics. It says that they're all related to home 1. These are all related to home 2. So don't confuse a label with actual variables. Okay, so variables come in two flavors, numerical and categorical. The reason why we make a distinction is that even though the statistics will be the same, how we use that statistics, or what we operate with them, will be determined by whether it is numerical or categorical. So numerical categories are kind of what you'd think they are. They're numbers, but sometimes it can be very subtle, that things that look like they're not numbers are actually numbers, and things that may be numbers may not be numbers at all. So sometimes we use numbers to represent categories, and sometimes we use categories to represent numbers. Anyways, you know, try to be clear about this when you're developing things, but also be careful. It's really the intent on how things are used. Numerical variables are intended to be used numerically. You're intended to be doing computations with them, like adding and subtracting, and generally measures of things. And categorical variables represent groups of things, like, gender, for example. You could be male or female, and you usually just count how many males, how many females there are. Whereas numerical variables tend not to be counted; they are measured usually, and they can be discrete or continuous. And usually the idea of discrete or continuous doesn't really matter too much for us, but it's often helpful to notice that it's one or the other. So continuous would be that sort of fractions and any sort of number is a legal or applicable valid data point for a numerical variable. Discrete would mean that there's only certain kinds of numbers, a finite number of numbers, or rather than any sort of fraction. Generally, when things are discrete, you'd have things like integers, like 1, 2, 3, 4, but it doesn't have to be that way. And categorical variables generally will have a group of categories. There's a rule of thumb that you can read that'll help you determine whether something is numerical or categorical. But definitely it has to do with, are you organizing things into groups and you just want to know how many are in each group, or are you looking at sort of a measure or a count of things? Not how many are in each group, but just sort of how many there are. Okay. So numerical variables, again, have some sort of meaningful values for their numbers, usually some sort of measures. For example, the price in dollars, and the measure would be dollars. Square foot, which is in square footage, and age is in years, and number of baths, again, are all things that probably would be considered numerical variables. Sometimes it's a little subtle, though. You can see that aircon here is 0 or 1. Now those are numbers, but they're not necessarily numerical. In this case, this is just a dummy variables that says that I use the number 0 meaning I don't have an air conditioner, 1 means I do. So this is actually a categorical variable, not a numerical, even though I'm using numbers. Similarly, sometimes you might use numbers that you might use letters or words to represent numbers, but we don't have any example of those here. So continuous, like price and square footage, would typically be considered continuous variables because you can kind of get all kinds of different fractions and their numbers in between, whereas age or say number of baths are probably not. Maybe age could be, but in this case it's not being used. But number of baths, definitely bathrooms tend to come in discrete units, 1, 2, 3, or maybe even 1, 1.5, 2.5, 2 3/4, but they certainly can't have any sort of fraction there. So baths would be considered discrete, and maybe square footage would be considered continuous. Okay, moving on, categorical variables. Categorical variables are just what you would think. They're categories of things, and they represent groups. So they also can be broken down into a variety of different flavors within that, but generally the statistics is the same. It doesn't really matter. So for example, I might have an ordinal variable. If there's some sort of order for the categories, then that would make sense for an ordinal variable. So for example, let's look at view here, view 1, 2, 3. So view 1 might be, nothing special. View 2 might mean a good view, and 3 might mean superior view. So in some sense, 1 is less than 2 is less than 3 here. That would be an ordinal variable. Or I guess it has no view, some view, good view, whatever. Whereas the categorical variable, say air conditioning, 0 or 1, there's really no order for that. Whether I have an air conditioner or don't have an air conditioner, I can't say one thing is sort of greater or less than the other. I mean, you could, but it depends on your intent. Nominal variables are variables whose categories cannot be put in any order, like air conditioning. And again, we typically don't really matter too much. It really only matters whether it's categorical or numerical. The thing about categorical variables that's important is to know that if it's categorical, what are the categories? There should be only a finite number of them, not an infinite number of them. And it should be the case that for any data that is valid, it has to be in exactly one of those categories. So in other words, we call those groups. So for every house, this meets the criteria. There's only two possibilities. Either has an air conditioner or it doesn't. There's no other possibilities. And every house either has one or does not have one. And therefore, it meets the definition of a categorical variable. So in this course, we're going to look at data, typically in these tabular formats, and process them accordingly as if they depending on whether they are categorical or numerical. So when we have categorical variables, that determines how we might describe that data by using various different tables, bar charts, and pie charts. We also, if we have numerical data, we might describe it with charts and numerical data, such as like frequency tables or a distribution. So you notice there's kind of a difference between the two. In other words, they're both trying to describe the data, but with categorical data, we have certain things like frequency tables and bar charts and pie charts, whereas with numerical data, we would describe it using frequency tables, a different kind of frequency tables. There's with frequency distribution tables and then histograms and distributions, as we'll see later on. We might look at relationships between categorical variables by looking at two-way tables and two-way charts. We might use we could have data that has numerical and categorical variables in it, and this is very common, where we might have a numerical variable that's organized or stacked according to categoricals. So maybe we look at you know years of experience for the MBA students. So years of experience in MBA students might be numerical variables, but then it might be stacked in terms of gender, male and female. So we could literally split up years of experience male, years of experience female into two different groups according to that. And that would be one numerical, one categorical. If we have numerical data, strictly numerical data, where we have two or more variables, we might describe the relationships between those two numerical variables or two or more numerical variables using, say, regression analysis. So again, if we have categorical variable, we might look at relationships according to one version of statistics, maybe chi-square tests and things like that, whereas numerical data, we might use regression analysis. Some things that we might use sample data for. So when we have data, we often talk about sample data, and there's a difference between the sample and the population. A population is all the possible data, whereas a sample is just a subset of that, something that we can get our hands on. And when we have a sample of categorical data, we might want to estimate something about that population, like the population proportion, based on that sample. And we do that based on a sample of categorical data, and we get a population proportion because the proportion of which category that I'm in or which group I'm in is what makes sense. If we had numerical data, it doesn't make sense to look at proportions of things. We might be interested in looking at the population mean, and we might use the sample to estimate or make a test, a hypothesis test about the sample mean, or the population mean, or the what we call the average. If we have a relationship between categorical variables, we might look at a test to see whether there's a relationship between them, and that would be maybe looking at the proportions, because proportions are the statistics that make sense for categorical variables. If we have a numerical and a categorical, we might take that numerical variable and split it up according to those categories, and then compare the different groups that we get from splitting it up against those categories. If we have numerical variables, we might look at relationships between two or more numerical variables by testing the hypothesis of the means between those, or medians, or maybe do, again, some regression analysis. So again, knowing whether I have categorical or numerical variables determines the kind of statistics that I can do, yet the same kinds of questions always apply. Is there a relationship? Is there not a relationship? How do you describe what that data is? So other things I might look at is estimating a value for y given an x, or a change in y. That would be looking at numerical variables for in regression. So that's about it. That's a quick overview. We'll talk more about these in detail as the class progresses.